Hi guys, Buildzoid here, and today we're going to be taking a look at another DDR5 overclock with the 9950X. This time we're on an MSI Mag X870 Tomahawk Wi-Fi motherboard, which was provided by MSI, so big thank you to them for sending the board over for testing. The memory kit I'm using is a G.Skill Trident Z5 RGB 2x16 7800 CL26 kit. And the reason I went with this kit, which was provided by G.Skill, originally they sent it to me for Z790 testing, but I never really got anywhere with that. So, yeah, I decided, well, partially I pulled it out because this kit hasn't really been featured in a lot of videos, and also because I'm like, I haven't gone through my Hynix A-die collection, which has recently grown to it's gotten significantly larger recently, to verify if this is true, but off the top of my head, I think this kit does the lowest timings, like lowest primary timings out of all of the Hynix A-die kits that I have. And for this setup here, I wanted to push the 1-to-1 mode of this 9950X basically to its limits, because while this 9950X is absolutely horrendous in 2-to-1 mode, in 1-to-1 mode, it's actually quite good. It's the best AM5 CPU I have currently for 1-to-1 mode. And even for like DDR5-6400, it really doesn't need a lot of SoC voltage, so I figured, hey, like it doesn't do 6600, but BCLK is a thing, so let's see what can be done with that. And then also I just, wanted to be able to run low primary timings when doing that, so that's why I went with this G.Skill kit. So yeah, thanks to G.Skill for providing the kit, and also the 9950X that I'm using is a retail CPU that I bought, so a big thank you to the channel supporters for funding the purchase of the CPU. If you'd like to support the channel, there are relevant links down in the description, so, I'd appreciate it if you'd check them out. And with that out of the way, actually, I guess I should point out there's also, well, let's just get into it. So, of course, you can see I do have a fan on the memory sticks because since I'm pushing the timings, like the primary timings as low as possible, I am running quite a high VDD voltage on the memory, and that does make it run quite warm, so the fan the fan becomes a necessity in order to maintain, like, refresh interval stability. So... yeah, also, if you're wondering how that fan is held in place, I'm using, like, super tall motherboard standoffs, basically, like this. And that fan is, like, the mounting holes on that fan actually line up with the mounting holes on the motherboard, because I think they're 80 millimeters apart, and I think that's an 80 millimeter fan, but I still haven't bothered to actually check that. But anyway, so yeah, so that's the physical setup here. And now let's take a look at the stress test that I've run and the timings. So as you can see, I ran 17 hours of Karhu, no errors, 6 hours of Prime 95 large FFTs. Also, no errors, no warnings, as you can see. Hardware info didn't catch any errors that weren't caught anywhere else. Y-Cruncher for over 2 hours, and this is just VT3, because while I was messing with 2-to-1 mode, on a different CPU, I actually found that, like, FFT V4, like, wasn't, like, it errored out, but it errored out on VT3, so I was like, well, evidently the other test wasn't worth running, because it errored, like, it was evidently not stable, and it ultimately errored out on VT3 anyway. Yeah, so that's that. And max memory temperature during this testing was 49 degrees Celsius, so that's kind of neat that it didn't bug out, but the voltage readings did bug out, which is annoying. Yeah, the memory voltage is set to 1.66 volts, which I'm honestly really surprised that that works, because I have sticks that need like 1.65 to do CL26 at 6200, and this is CL26 at 6500, so... yeah, I really need to go through my Hynix A-die collection and, like, rank the kits by minimum CAS latency for a given voltage. Actually, no, I don't want to do minimum CAS latency for a given voltage. I want to do minimum voltage for a given CAS latency at, like, 6400 or something, is what I'm thinking. And the reason I'm thinking 6400 is I don't really want to have to run BCLK for it. So yeah, and I do want to be in 1-to-1 mode because like I might also test like 2-to-1 mode behavior. But the thing is, 2-to-1 mode brings up all kinds of its own issues. So like if it goes like if I test it above 7600, I think it'll get really annoying. Is basically my main concern. And testing at 7600 is kind of pointless from like a performance perspective. But anyway, yeah, so honestly, I'm surprised that like CL26 at 6500 even works. Because I have kits where this probably wouldn't even post. Yeah, then the SoC voltage, it is actually set to 1.285. That's not like a reading error. I did consider setting it all the way to 1.3 volts and then like trying to push the BCLK even higher. But the thing with BCLK overclocking is that it has a tendency to break things. Because it overclocks everything, right? It overclocks your CPU, it overclocks your PCIe, and so I don't really consider what I'm showing you here. Like, I wouldn't recommend that you, like, the timing, like, you could copy the timings and run them at, like, 6400. Assuming that your memory kit is good enough and your CPU is good enough, that should be just fine. I'm not sure I would recommend that most people actually just, like, push the BCLK. Now, it's not like I'm pushing it a lot. It's 101.6, so it's like a 1.67 megahertz BCLK increase, which it's rather unlikely that that's actually going to cause any major instability. But at the same time, it's also not going to, drastically improve performance. So why would you risk it is kind of my question, especially for a daily system, right? So this, like, I really do consider this more of a kind of just for fun showing off kind of thing rather than I would build my system around this. Even though like it does pass everything, I didn't notice any weirdness with the setup. But yeah, I'm not like you could just run this at 6400 and then you don't have to like there's no like at 6400 you don't have to worry about the whole like oh the BCLK is getting raised. So yeah, so that's basically everything I wanted to show in the OS. CPU maxed out at like 93 degrees because Prime 95 large FFTs does get really hot for certain parts of the test. So not that it like pulls a ton of power. I mean, it does pull quite a bit of power, but it's more like it peaks some of the cores rather than like being because there's other tests that'll run the whole like the overall CPU power consumption is going to be higher, but the peak temperature is actually going to be lower. So Prime 95 large FFTs is just rather peaky in terms of temperatures. Anyway, I think that's everything I wanted to show in the OS. Because everything else, I think we're going to be looking at the BIOS. Yeah, so basically the main concern I have with this is just like the BCLK. And kind of the FCLK, but this is a CPU that does, like, it boots 2233 and is even kind of functional, so 2170 I wouldn't be too worried about. So that was the other reason I didn't like want to push the BCLK super high and like raise the SoC voltage even more. Because based on how the chip behaves at 6600, like DDR5-6600, I would honestly guess that at 1.3 SoC, it probably could run like 6550 or something. And I was considering like lowering the BCLK instead of raising it, right? Because if you're at 6400 to get up to say 6550, right? So 6500 divided by 64, like that requires 101.6 BCLK basically. But I was thinking, well, if I wanted 6550, right, and then use the 66 ratio, then I'd only need like 99.2 BCLK, and that also could, like, with the thing with BCLK is it's not necessarily, like, it's not inherently that raising it causes instability, it's just if it's too far from where it's supposed to be because it affects things like the PCIe, it can break stuff, because certain devices just don't tolerate a significant deviation in their like connectivity speeds. Right, like they expect the PCIe to be running at a certain speed, and if it's 5% too high, then it doesn't work, and if it's 5% too low, then it also doesn't work. But this would basically need much less of a BCLK adjustment. Now, obviously, the downside to going from 66 down is that it ends up slightly underclocking the CPU, right? This would be a 0.7% underclock on the CPU, but you could potentially offset that with, I mean, on a motherboard with ECLK, you could just use ECLK to work around that. And alternatively, you could like mess with PBO to basically make up the gap. But on this motherboard, you can't lower the BCLK. And actually, I think a lot of motherboards don't let you lower the BCLK, which is kind of weird that they only let you raise it up. So, yeah. So, and the thing is, once you start, like, up to around 102 BCLK, I would not be that worried about it causing issues. But past 102, I would start getting concerned. About it potentially causing issues with things that aren't necessarily just like the memory stability or the Infinity Fabric. So, yeah. Anyway, so yeah, it passes all stress tests. Like, this is, from a stress testing perspective, this is stable as far as I'm concerned. The thing is, like, I'm not really aware of a good way to verify how this would interact with, like, mainly PCIe devices. Right, and GPUs generally don't complain too much. I'm more concerned about things like USB, well, not USB, M.2 drives. Though I do wonder if the high-speed USB ports wouldn't get out of whack because of this as well. Yeah, that could also potentially be an issue. But anyway, so yeah, I wouldn't, like, this isn't something I would, like, recommend people replicate, but these kinds of things can be done, is basically like the point of this video is like, yeah, something like this can work, and at 6400 this would actually be very because it works so well at 6500, at 6400 I'd really not be concerned about this not working. So anyway, let's go into the BIOS. Not that I had to make too many adjustments, though I will say I am not a fan of the new MSI BIOS. It's ugly. And it has some weird quirks that I'm not a fan of. So I do appreciate the post code on this board. I mentioned that in the PCB breakdown. We do have fast boot turned on right now, so like memory context is enabled. So yeah, it doesn't really take a long time to post after it's already figured out the memory training. And here we are. And yeah, this is the new MSI BIOS. My first complaint is that it doesn't start us in the overclocking menu, which, if I remember correctly, the old one did. Yeah. So, anyway, so we've got BCLK over here. Also, I'll point out that I'm pretty sure if you try to disable this, it causes the board to not post. So that seems to be bugged out. And another thing that I was having issues with is adjusting the VDDGs. Yeah, those are on auto right now, because I tried messing with these, and it was not happy. So I haven't, like, that potentially needs more testing, but yeah. So also you can see that the SoC voltage, I have that set to 1.285. The SoC voltage reading in the BIOS is not accurate, because this is from the Super I/O, it's not from the DiSense, so we're not, like, that's not measuring the voltage that the CPU is getting, that's measuring the voltage at the CPU socket. Though I will say MSI's, I'm not sure if this is a matter of, like, MSI's SoC power plane being better, or if they just moved the measurement point closer to the CPU. This is not as far off as it is on Asus boards. Like, Asus boards, their SoC voltage reading in the BIOS, and, like, the SoC voltage reading from the Super I/O on Asus boards is just sky high. It's just insanely incorrect. Probably and I don't know if it's because the power plane is, like, super narrow and the sensor is, like, really far up it, or if it's because the power plane is like, the power plane isn't super narrow or anything, but the sensor is positioned really badly. Because basically, Like that's the annoying thing with measuring voltages on high current rails is depending on how close to the voltage regulator you measure the voltage, you get a drastically different voltage reading. And obviously the silicon doesn't see what is like the voltage at the voltage regulator, right? Because the voltage is always relative between 2 points. So the voltage drop across the silicon, that's the one we care about. We don't care that there's like 30 millivolts of power loss in the power plane getting to the silicon, because the silicon doesn't see those 30 millivolts because they're gone. They got burned off in the power plane. But anyway, so yeah. So for now, I'm using AMD overclocking mode. The reason I'm using AMD overclocking mode is because on the one other MSI board that I've used, the override mode was like very buggy. I don't know if that's still the case with this board, because I kind of wanted to throw together a memory overclock pretty quickly. But yeah, so AMD overclocking mode works like it just like it does what I want it to do, and I didn't bother to investigate how override mode behaves. Now, here's a complaint I have. So as you can see, DRAM voltage, I have that set to 1.66. This is not completely minimized. Like I didn't lower the VDD voltage to the point that the memory stops posting or that it starts being unstable. Which usually the difference between those two is like 10, 20 millivolts with Hynix chips. Is that they break pretty clean, which is nice. Because there's some memory chips that like you have like a 50 millivolt margin of like, oh, this boots to this is actually stable. Hynix chips seem to have a pretty narrow gap between boots and is actually fully stable. But yeah, so this isn't completely minimized, which I still kind of can't believe that the voltage can be this low for CL26 at 6500. But the thing is, if I change the memory voltage, it changes the VDDQ voltage and the VDDIO voltage. I am not a fan of that. I like on past MSI boards, it was possible to, I think on Z690, and I think even the B650 board I have, it was possible to like unlink the memory voltages, and that's not an option here. So basically, every time you adjust VDD, you have to also fix your VDDQ and your VDDIO. Now, I didn't investigate if this board has like a optimal VDDIO, VDDQ value. In 1-to-1 mode, that's not really much of a concern. For 2-to-1 mode, it's a major concern because VDDIO is like signaling voltage from the CPU. So this is basically the voltage that the CPU uses to like send data to the memory, as well as like commands and stuff. And this is the voltage that the memory uses to send data back to the CPU. So both of these voltages actually like directly interact with your termination resistances, drive strengths, and the topology of the motherboard. And so if these are set too high or too low, it'll destroy the signal quality, right? But that really varies by motherboard. And the reason I went with 1.4 volts is because 1.4 volts is a very typical XMP expo voltage. So the board should be designed to work with that, right? Was sort of my thought process is like, well, most expo kits and most XMP kits are like 1.35 volts up to like 1.45 volts. So the board should probably work fine with 1.4. So yeah, and also we're in 1-to-1 mode. So the signaling it's not as critical to have the voltage just right. Yeah, so these, like, neither of these is minimized, but 1.4 volts it's not going to hurt the memory chips, it's not going to hurt the CPU. I know the BIOS highlights them red, but these are fine. Like, I have absolutely, like, I would not be concerned about this in the slightest. So that's the voltages, and then I didn't adjust anything else. It's worth noting that MSI bumps the VPP voltage by 50 millivolts. By default, it's supposed to be 1.8. This might slightly help memory stability. I don't think it actually does anything. It definitely doesn't harm anything. So yeah, that's just like a detail I noticed. It's not really anything significant. It's just like, oh, they're bumping VPP because by DDR5 spec it's supposed to be 1.8. And as you can clearly see, it's reading 1.85, and that is real. Like that is a thing that MSI has done on a few boards in the past as well. So, yeah. VDDP, I did have to lower this. This board likes to set VDDP like pretty high on auto. And the problem with that is it causes both Y-Cruncher and Prime 95 will just reset the system if VDDP is way too high. So, yeah, like it probably also happens if you set it too low, but I didn't try lowering VDDP more than basically this. So, yeah. And also in one-to-one, well, yeah, that might need more testing. I guess we'll, like, as I do more testing in 2-to-1 mode with this board, I might have stronger feelings about VDDP settings, but for now, 0.965 works great, so that's, like, it's not, like, this is a perfectly good voltage. It's not going to hurt anything, and it's stable, so I'll call it a day. I didn't bother adjusting any of the load line settings, because doing that without the... Yeah, like, basically adjusting these without the oscilloscope to me seems kind of pointless, because I won't really know what's going on anyway. And especially for SoC voltage, like, it shouldn't really be necessary, because it's not a very high power rail. And as far as I know, on the AM5 socket, the stock load lines are extremely shallow anyway, so the voltage that you set is basically going to be the voltage you get. Because just AMD has very shallow load lines. That's how they're designed their CPUs. So memory settings, 64x ratio, 2133 on the Infinity Fabric, which obviously gets brought up by the FCLK, and also, not the FCLK, by the BCLK being raised. And with the Infinity Fabric, this is in the 2-to-3 ratio to 6400, right? 2133 is 2/3 of 3200, because that's like DDR, so you'd have to divide that by 2, and that gives you 3200, and then you divide that by 3, and then multiply by 2, and that's how you get 2133. And that gives you the best memory latency in 1-to-1 mode, because it just it gives you the best memory latency in 1-to-1 mode if you can't run like super high FCLKs. Which really isn't for like 6500. That really isn't an option, because the next step up is going to be like 2200, and that drops out of that 2-to-3 ratio. And the 2-to-3 thing is basically just a buffer optimization, because the Infinity Fabric and the memory controller in 1-to-1 mode are not synchronized, so the data gets buffered. But if the buffer is like if the Infinity Fabric is checking the buffer every every 6th clock cycle basically is aligned between the memory controller and the Infinity Fabric, and so that like works out in favor of the latency for some reason. So that's not like a theoretical thing. That's like from a like testing. That's just what you end up at, is just the 2-to-3 ratio has a slight latency advantage over just like over, say, 2166 or 2100 in this setup. In this setup, right? Anyway, so for 6400 for 6400 optimal FCLK is like 2133. If you have something that really needs memory bandwidth, it would alternatively be 2200. But yeah, that's obviously not an option when we're pushing the BCLK by 1.5%. Or like 1.5, 1 point, actually it's not 1.5, it's like 1.67%. Actually, we could just read it. Yeah, it's like 1.6875% extra BCLK. So that 2200 is not an option, because that's going to be 2222 something, right? Like that's going to be over 2200 FCLK, and that's just going to be completely unstable. Because like there are Ryzen chips that'll go over 2200 FCLK, but they are not common, and this is not one of them. In fact, they're extremely rare. They're like rarer than the chips that like work at, say, 6600. Anyway, also this is where you set the 1-to-1 mode. So UCLK equals MCLK. That's 1-to-1 mode. let's take a look at the timing. So cast latency 26, TRCD 38. I didn't actually check if 37 would work. It might. If it does, I would be very surprised though, because yeah, like at 60, like 37 TRCD at 6500 is like that's very tight. TRP 30, which is also really low. I didn't check if 28 crashes. It probably does. TRAS 30, I think. Oh yeah, this board doesn't stop you from setting TRAS lower than that, which is weird. That is very weird. Because as far as I know, there should be a register limit at 30. So, yeah. Anyway, TRC is 60. I'm just setting it to TRAS plus TRP. TWR is 48, which is actually like register limited. You can't set it any lower than that. TRFC1 set to 411. It would probably still work even at 400 for 6500, but I don't really see much point in like, tuning TRFC by like 10 more cycles or something when your refresh interval is 65,000. And you know what? I'm actually going to make this bigger because like the BIOS, this is probably my least favorite thing about the new MSI BIOS is that the text is smaller compared to the old one. Anyway, the other two TRFCs don't do anything, so I set them to the meme number. Actually, I guess I could have also set them to this instead. But yeah, like neither of those TRFCs is actually used by the AM5 memory controller, so we can just set them to whatever. So 69 it is, because that's nice. Anyway, RTP 12, I didn't bother to check if less would work. Sometimes it does, sometimes it doesn't. I think it depends on the memory kit. I didn't actually verify if like 8 works in this setup. It might. TRDL at 8, TRDS at 4, TFAW at 16. I am not convinced that TFAW value is actually real. I think this is a similar situation to the TRAS register on this board, where the board just lets you set it below where it can actually go. But the good news is that with DDR5, since your burst length is 8 cycles, this really doesn't matter that much, the TRDs. And like TRDL, TRDS, TFAW, as long as they're not higher than like 832, well, it depends on the memory chip, because there's some memory chips that won't do TRDL8 at, say, well, at 6500, I think basically everything will do 8. But at higher speeds, there are some memory chips that won't do TRDL8. Yeah, so this isn't like the funny thing is, there was a live stream relatively recently with, I think, an Asus board, because Asus also doesn't like enforce the 20 cycle TFAW limit, where I tried testing the TRDL, TRDS TFAW thing, and it just ends up being margin of error. So yeah, that's basically my argument for why that's at 16. It doesn't really seem to make a difference compared to setting it to 20, because either the memory controller is correcting it back up to 20 anyway, or it just doesn't matter because this is DDR5 and the burst length is 8 cycles. So, like technically, the memory controller might be able to squeeze in a couple more activate commands and like schedule other commands around activate commands more efficiently, but it's not like DDR4 where your burst length is 4 cycles, so if you have a TRD of more than 4, you're literally, delaying read operations directly. Anyway, WTRL and S at 14 and 2, which is very tight. Though I didn't bother to check if 12 would work. I kind of doubt it. Because, yeah, admittedly, I am running kind of a lot of EDD, and WTRL might scale with that a little bit. Yeah, so 14 and 2 on those, which is basically as tight as I've ever run these. And then SCLs, we got 4 and 1 for, well, read to read, 4 and 1, which that's like what you usually use for 1-to-1 mode on Ryzen. Right to right, 2-in-1. Like the thing is with the right to right timings on Ryzen, you could probably set this to 1 as well. But I think that's just like an anomaly of the AMD memory controller rather than something real. And also like 1 and 2 are kind of the same thing. And WRD 2, this is another one of those that sometimes you can just set it to 1 and it'll just work. So yeah. Also, I'm pretty sure WRD overlaps in functionality with WTR, because this is like write to read, and this is write to read. Like the WTR stands for write to read, and the T stands for two, and WRRD like WR is write, RD is read. So I kind of suspect that like these two take priority, especially on a single rank configuration. I'm like, I have a theory that this might not actually do anything, or it overlaps with the other two. So if you set it lower than the other two, it doesn't do anything. Anyway, I've set it to 2, so yeah. And then we have read to write, which is at 16. And I didn't check if that would go lower. It probably wouldn't at 6500. So yeah, and this is separate from WTR. Like this controls the like transition from a read command, like, well, not the transition, but the gap between a read and a write command. Because when you're switching from read operations to write operations, it takes a while because just due to how the operations work. I'm not going to try to explain that right now because I've forgotten it. Anyway, the different there, like there's a specific reason for why there's a difference between these two, but I just don't remember it right now. And like these are completely independent is the main point I'm trying to make. Even though like they're kind of like they're right next to each other, and I kind of tend to think of them in my head as like a group. They are completely independent. They have nothing to do with each other. But anyway, as you can see, right, so I turned TSME off. I'm pretty sure TSME is turned off by default because it just makes your memory performance worse. It's a security feature that just makes memory performance worse. Not like unless you're renting servers to people, I don't really see a reason that you should be turning this on. And then I've turned on DFE read training, which I also think is turned on by default. Like, as far as I know, most TSME, as far as I know, should be disabled by default. And DFE read training, I think, is enabled by default. But basically, especially on like 4-DIMM motherboards, which this is, right? It has 4 memory slots. DFE read training can improve signal quality through some electronics engineering magic. We're not going to get into it right now. So turning that on can help. Well, if it isn't already turned on by default, turning it on can help with memory stability at high speeds. I don't really think it's super necessary for 1-to-1 mode, but it might also be turned on by default in 1-to-1 mode. And then what you see down here with these being set to 0, that isn't for me. That's just what the motherboard defaults to. So, yeah, I didn't have to tune any of the drive strengths or terminations for this setup, but we're in 1-to-1 mode, so that's not super surprising. And also, like, ideally, MSI would have, tuned those settings themselves in the BIOS for the motherboard. Because the idea with these is that they're supposed to match the impedance properties of the memory topology on the board itself. And so that's something MSI should actually be configuring for you. Now, that doesn't mean every motherboard manufacturer does a good job of it. But this usually doesn't become a concern until you're pushing high speeds in 2-to-1 mode. And my 9950X already, like, it really sucks in 2-to-1 mode. And it's not because of terminations. It's just really bad in 2-to-1 mode. So, I haven't seen much reason to try messing with that yet. Actually, I did slightly try to tune because I did briefly test 2-to-1 mode with this CPU on this board, and I did try to mess with the terminations a bit to see if it would get any better. I made it worse, so I guess MSI did actually tune them properly at like out of the box, or not really out of the box because I did update the BIOS, right? But so this isn't the out of the box BIOS. This is like the latest. It's not the latest BIOS, but yeah, I did update the BIOS when I got the board. So it's not like some early beta BIOS for this board. So anyway, yeah, that's it. I wouldn't actually recommend that you copy the BCLK overclock here, and also, even if so, like the settings I've just showed you, if you run them at 100 BCLK, I would actually, like, if your CPU is good enough, right? Because that's the main thing, is DDR5-6400. A lot of CPUs will not run that in 1-to-1 mode. They just won't. Even if you set the SoC voltage to 1.3 volts, it won't be stable. But if you get lucky with your CPU, then these settings, especially with 1.285 SoC, like you won't even have to get that lucky. These should just work on like better kits of Hynix ADI, because I do think there are some sticks that like at 6400 you won't be able to do TCL26, even with 1.66 volts of VDD. Yeah, if you want to push your memory kit, but at 1.7 volts, I think basically any kit should probably be able to do 6400 CL26. So that's 1.7 here. And again, if you set this to 1.7, you're going to have to correct the other two because, yeah, the board sets them to match VDD, which, like, doesn't... Like, it makes sense from, like, an XMP Expo perspective, because if you're on XMP or Expo, it's never going to be more than 1.45 volts, but, like, setting VDD I/O to 1.7 volts is not reasonable, as far as I'm concerned, at all. VDDQ, you might have an argument for that sometimes, but for a VDD I/O, it, like, actually just does, like, that really, it doesn't make sense to me. And it might actually be dangerous for the CPU, because VDD I/O goes to the CPU. Whereas these two are for the memory sticks, so I'm not, like, super concerned about those. Because at this point, I've run Hynix sticks at kind of silly voltages for, like, a lot, so I'm really not worried about that. Anyway, so, yeah. That's that for this setup. Really, this is meant more to be like an inspiration of like, oh, this is the kind of thing you could do rather than something you should do. And also it was for me to like see, like getting a feel for the board. And on that note, like, I'm really happy that the clear CMOS button just works. I have another X870 board where it doesn't just work. So, yeah. Anyway, that's it. So hopefully you found this somewhat interesting, if not particularly helpful. And thank you to MSI for the board. Thank you to G-Skill for the memory kit. Thanks to the channel supporters for the CPU. And thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon and a Spring store with like shirts and hoodies and posters, and there's just like links in the description if you'd like to support the channel. You could like check those out, and I would appreciate that. And yeah, that's it. So thanks for watching, and goodbye.